So कैसे हैं आप लोग? I welcome you all in my YouTube channel Coding by Fun and let's get started. So after a long time I started again the competitive programming and we are starting with the tree data structure. So the question is to count the leaves in a binary tree. So as you can see over here, yeah. So there are you can see in this question there are two leaves in this tree. Okay, and in the below tree, if you will get to know, there are 1, 5 and 3. These three are the leaves. So what are the leaves? What's left and the right nodes are null. So you can say that is a that is a there you can count those leaves, right? Okay, so let me show you. uh, this is 1, 3, 5, and let's say this is 7. Okay, so the seven left tree is also null and right tree is also null, right? So this is a leaf node, or you can say this is a leaf. Similarly for 3, there is no left, though no right node, so it is also leaf node, or you can say leaf node. And also the 5, but 5, the left node is null, but right there we have the right node, right? So this is not a leaf node. There are two. Similarly for this, we have two. Similarly for this, we have 1, 5 and 3. So we have to count such nodes. So I have I have written the code over here, so you can check it and let me explain you one line by line. So if the root is null, so if there is no root, or if there is no any root, then we can say, right, there is no left node if the tree is empty, correct? So we'll simply return 0. Otherwise, we are checking if the roots or any nodes left or left node and the right node are null, then we are simply returning 1. Similarly, we are counting this for left and right tree both, and we are returning left and right. So let me explain what is this left and what is this right. 39, 10, 5. Okay. And okay, let's check for this example only. So firstly, what we are doing, if the root is null, so no root, this is the root, root is not null. Okay, root is not null. Now we are checking if the roots left and right are null, no. So we are coming to this point, count L, C. So we are going to count leave, we are doing the recursion call for the roots left. Now we are over here on the 10. Again, root is not null, left, right is not null. Again we are counting it. So we are on node number 10 and now we are on node number 5. We are on 5 now, okay? Now, root is not null because 5 is not null, and root left and right is null. So this 5 will return 1. Okay, this 5 left will return 1. So we are getting over here is 1 CL. Right? After this, it will go to this line, right? First it will execute the left one, then it will execute the right one. So now we are in the right, C right. Okay, for the 5. Okay, so for the right, so 10th right is null, so it will not, uh, it will return 0, right? If the root is null. So 10th left was 5, but 10th right is null. Not 5 is null. So it will simply return 0. So from here, from the right side, you will get 0. And for the left, you will return, you are getting the 1, right? And at last you are returning count L plus counter. So you are counting for both the things, right? For the 10 you are counting for the left and for the right, so you are getting only 1 plus 0 1 as a output over here. That is 10 is connected to one such node, who is the leaf node. Again, for right, once right, root right, it will count r, it will go to the count like roots right. We are here now. We'll check this is null, left is right, neither, so it will return 1. Okay, it will return 1. And this 10 is also returning 1. So 1 and 1, 2. So we will get 2 as an output because we are returning count L plus count R. So this is the simple code. You can check the code once again. Like if the root is null, we are returning 0. If the root's left is null and root's right is null, we are returning 1, and we are going in the left subtree and we are going in the right subtree, and we are recursively calling the same function for the all the left nodes and all the right nodes, and we are returning just the summation of the left and the right subnodes. Okay, and also you can write instead of this, like if you might be confusing, so you can write if root slab is equals to null. So this is also you can write right, and you can give an end condition and roots right equals to null. So this is also a valid condition and it's a same condition. And over here we are saying root left is null. Okay, so this is how we read it. So I hope you uh, got the point and you got the code how we are doing it. Yeah, so see you in the next video.